Hi, and welcome to your 4-3 flipped video. 4-3 is all about adding rational numbers. 4-2, if you'll remember, was out to add integers. So to add rational numbers, let's first review what a rational number is. It's a number that can be written in the form a over b or negative a over b, such only if b is not equal to 0. Okay. So the only difference between a rational number and an integer is integers were negative numbers, -2, -1, -3, -4, -5, all the way to -1,000,000, 0, and 1, 2, 3, 4, 5, 6, all the way up to infinity. I meant negative infinity. So it's all the negative numbers, all the positive numbers, and 0, with no fractions or decimals. Rational numbers include the fractions and decimals, okay? So let's look at an example. 4 nines plus -3 nines. So I'm sure in your brain you're going to say, well, I have 4 nines, and I take away 3 nines. That means I have 1 ninth left over. But we're going to practice a skill here of using different mathematical properties in order to make this a more easier problem to look at. And I'll walk you through them. You don't have to know the names of the properties, but you should be able to replicate this process regardless of the numbers. So what we're going to do is we're going to split up 4 nines into two different numbers that when added together will give us 4 nines. We learned in 4-2 about additive inverses. So if you add a number and its opposite, so like 2 and -2, all additive inverses add up to 0. So I see I have a -3 nines off to the side, so if I split 4 nines, I'm going to try and split it up to give me a 3 nines off in one of those two parts. So let's start there. If I split 4 nines and one of those parts is 3 nines, what's the other part? Well, if you pull 3 ninths out of 4 ninths, you have 1 ninth left over. All right, and so I'll put some parentheses and a plus sign to show that the sum of 1 ninth and 3 ninths is 4 ninths. The combination of it together. It's replacing the 4 ninths with this combination, and then I'll keep the rest of the problem the same. And all I did there was I split it apart. So now we're going to use the associative property of addition to just move the parentheses. So exact same numbers, exact same order, exact same symbol. All I did was I moved the parentheses. But now I have the additive inverses right next to each other. So when I add those together, they're always going to be 0. So the 1 ninth isn't changed. And so I get 1 ninth plus the sum of additive inverses, which is 0. So 1 ninth plus 0, which is just 1 ninth. So the answer that you knew off the top of your head. We'll do one more this way. 10 11ths plus -3 22nds. Different denominators here. So we have to do this little side step of 4. We have to get the same denominator. So which one has the smaller one? Well, 10 over 11 has a smaller denominator. So I'm going to multiply it by 2 over 2 to give me 20 over 22. And then I'm going to keep the plus -3 over 22. I'm going to do the same split, so I have a -3 over 22. So I'm going to split the 20 over 22 to get a positive 3 over 22, so I'll be guaranteed to have additive inverses. So let's start there, 3 over 22. So if I pull out 3 over 22 out of 20 over 22, what do I have left over? 17 over 22. I'll throw parentheses and a plus sign to show that it's not anything new. It's just replacing the 20 over 22. And then I'll keep the plus -3 over 22. And I'll use the associative property of addition to change my parentheses location. And now I have 17 over 22 plus the additive inverses, which gives me 17 over 22 plus 0. So it's just 17 over 22. This may be easier than finding common denominators and then lining it all up and subtracting. But we'll go through that a little bit more later on. This is just another way of thinking about it, just like how integer chips were another way of thinking about the number line and adding and subtracting integers. Okay, we can also use this this procedure to add and subtract decimals. So if I do 11.4 plus -19.5, this would be rather annoying even if you set it up and solved it longhand, but I can split it apart. So in this case, the second number, the -19.5, so the second number and the negative number is the larger of the two, so I'm going to split that one up, and I have 11.4 off to the left. So when I split up the -19.5, I'm going to split it up so that I have a -11.4 in one of those two places. And if you pull out 11.4 from a 19.5, you get 8.1. So 11.4 plus -11.4 plus -8.1 gives me -19.5. going to keep the 11.4 that was there, and now commutative or associative property of addition, switch the parenthesis orders around. So we have additive inverses next to each other, which add to 0, giving us 0 plus negative 8.1, which we know is just negative 8.1, because any number plus 0 is just that same number. So we have two categories of numbers. If you add two numbers with the same sign, and next we'll look at two numbers with different signs. So if you add two numbers with the same sign, either they're both positive or they're both negative. So an example of this would be 1 plus 2. Let's do an easy one. So if you start at 0, you go to the 1, because you start off at 1, and then you go 2 more to the right, because you're adding a positive. So where are you? You're at 3, so 1 plus 2 is 3. I know, just really difficult stuff here. Negatives, negative 4 plus negative 1, so you start at 0, you move 4 to the left because you're at negative 4, and then you're adding a negative, so you're going to continue going 1 to the left, so you get a grand total of negative 5. So there's some steps and ideas that we can derive from this pattern. So the first one is same symbol, or same sign, right? Both positive or both negative. The arrows go in the same direction. Both of the red arrows are pointing to the right. Both of the orange arrows are pointing to the left. So same symbol, or same sign, same direction. Then digits describes this step as if you add the absolute values. I put a box in the absolute values because I didn't want to put a number or a variable in there that might confuse you. So add the absolute values and use the sign, all right? Because they're both going to be the same sign. Either they're both positive or both negative. You just use whatever sign it is. So let's look at an example of that procedure. If you have negative 2.1 plus negative 4.3, take the absolute values. So absolute value of negative 2.1, and you're going to add them. So plus the absolute value of negative 4.3. So how do you take the absolute value? It's the distance for that number is from 0 on the number line. So basically you just chop off the negatives, and if it's positive, you leave it alone. So you get 2.1 plus 4.3, which you can do pretty quickly as 6.4. And now you're going to use the sign of the two original numbers. So they're both negative, so I'm going to turn 6.4 into negative 6.4. If it was positive 2.1 plus positive 4.3, my answer would just be 6.4, and I would be done. All right. I think it's a little bit easier when you think about it in these steps. You ignore if the numbers are positive or negative. You add them together, and then if the number is positive, then you keep the positive sign, and we don't write that in. Or if the numbers were negative, you throw a negative sign on it. All right. So an example of this would look like negative 31 plus negative 23. I'm just going to ignore the symbols and do 31 plus 23, which gives me 54. And now I see they're negatives, so I'm going to throw a negative, and then I'm done. All right. So it's the same process. You know, I'm taking the absolute value, but I'm not officially saying I'm taking the absolute value. It's the same steps. It's mathematically the same things are going on. I just think it's easier if you think about it like this, where you're ignoring the signs, adding them, and then reapplying the signs later on. All right. So the other example is adding two numbers with different signs. So we'll walk through two examples really quickly. 3 plus negative 2. So you start off at 0. You move to the right 3 because 3 is positive, and then you're adding negative 2. Negative numbers go to the left, so you move 2 to the left. So where are you? You're at positive 1. So 3 plus negative 2 is positive 1. Same thing for negative 5 plus 7. Start off at 0, moving 5 to the left because it's negative, and now you're going to move 7 to the right because you're adding a positive. So where are you? You're at positive 2. All right. So what do we see here? Well, arrows go in opposite directions for opposite types of numbers. So a positive and a negative, the arrows will go in opposite directions. All right. Digits says this process is subtract the smaller absolute value from the greater absolute value, then use the sign of the greater absolute value. All right, I know that's a little confusing, so let's look at an example. 14.2 plus negative 15.3. We're going to subtract the smaller absolute value. Well, 14.2 is smaller than 15.3, so I'm going to do the absolute value of negative 15.3 minus the absolute value of 14.2, because I'm subtracting the smaller number from the greater absolute value. So negative 15.3 minus 14.2, minus absolute value of 14.2, gives me 15.3 minus 14.2, because the absolute value of negative 15.3 is just 15.3. The absolute value of 14.2 is just 14.2. So I get 15.3 minus 14.2. So I'm going to subtract those two, which gives me 1.1. Now I'm going to look back at my original answer, my original setup right here, and say which one is the greater number. Well, 15.3 is greater than 14.2. We already established that. So I'm going to say 15.3 is negative, so I'm going to turn 1.1 into negative 1.1. Okay? So I think, again, there's an easier way to think about that. Ignore the positive or minus sign. Subtract the two numbers, so subtract the smaller one from the bigger one, and then use the sign of the larger one. It's the same steps, but I think it's easier when you think about it in these three. Ignore signs, subtract smaller from bigger, use the sign of the bigger one. All right, that does it for 4.3. If you have any questions, let me know.